Welcome back to geometry. We are at 3.4, parallel lines and triangle sum theorem. The way that we name triangles are with angles and sides. So the first angle that we now know about is we have an acute angle. And so we also know that we have an obtuse angle. And then we also know that we have a right angle. And remember that when we form a triangle, we have one angle, so this angle could be acute, obtuse, or right, and then we form our triangle. Now the sides, new terms here, we have what's called scaling, okay, which means all sides are different in a triangle. So let's draw, say this was a 4, a 3, and a 5. This would be our scaling triangle because all sides are different. We also have an isosceles triangle, and that's going to be where two sides are the same. And one thing to note here is that when two sides of a triangle are the same, their opposite angles are also going to be the same. They're also congruent. So I can put a mark and a mark. Okay? And then we also have an equilateral triangle. And equilateral would be all sides are equal. And we can show that with a mark, and a mark. And when that happens, we also create what's called an equiangular triangle. So these two terms are very closely related. In terms of triangles, they are the same. And here's why. Because with an equilateral triangle, that means that all angles are also going to be equal because all their sides are equal. So if you were shown an equiangular triangle, where you weren't shown that all sides were equal, but you knew that all angles inside were equal, then what you can say is since all these angles are the same, their sides must also be the same. So we name triangles first by the type or types of angles that they have, and then by the sides that they share in common. And if they don't share any sides in common, it's always just going to be scaling. So in drawing our right isosceles triangle, we want to draw a 90-degree triangle. Let's put a box. And then we also need to say that two sides are each congruent. So let's put a mark here and a mark here. And so this would be our case of a right isosceles triangle. Also, since these two sides are the same, I would know that these two angles have to be the same. Furthermore, since I know that this is 90, that means these angles would have to be 45 degrees and 45 degrees, which we'll learn more momentarily. Alright, next we have an obtuse scalene triangle. So what does that look like? Well, we want to start with an obtuse angle, so we'll open it up. And then here comes our triangle. And so let's put that this angle is 110 degrees. Furthermore, since this is scalene, all sides are different. We'll put one mark, we'll put two marks, and we'll put three marks. And that shows that all these lengths are different measurements. For the equilateral triangle, we have a triangle where all sides are equal. So we'll put a mark, and a mark. And an equiangular triangle, that means all angles are equal. And we'll put these marks in here. Now also, let's add more marks. We'll be as thorough as we can. We know that all these angles must be the same. And we know that these sides must be the same. We also know that all of these angles inside here must be 60 degrees all the way around. And the reason why we know that leads into our next theorem, which is called our triangle sum theorem. which says the sum of the measures of the angles of a triangle is 180 degrees. Alright, Euclid's parallel postulate, we're going to skip, so we don't have to worry about that one. Next problem, we have a triangle again. There's 180 degrees total in all triangles, so we add up x plus 2x plus 8 plus 4x plus 11. It's going to equal 180 degrees. Solving for x, we have 7x equals 161, x equals 23. So I have 23 degrees here. I get 54 degrees here. And that means I'm going to get 92, 103 degrees here. And always check to add all these angles up to make sure that it adds up to 180, which it does. Alright, so if we're going to classify this triangle, since we have an obtuse angle, this is going to be obtuse. And since all angles are different, that means all sides are also going to be different scaling. Alright, next triangle, we have 3 triangles in one. Here's one triangle in blue, the medium-sized triangle. We have our small triangle in green, and then the big, large triangle, I'll outline it, this huge one, it goes all the way up to here, and all the way back around. So 3 triangles in one. And we have to look at each triangle to solve all of them. So first, alright, let's look at our linear pair first. 134 and z, this forms a linear pair. So z has to be 180 minus 134, which is going to be 46 degrees. Next, I know that angle y plus 46 plus 61, there's 180 degrees in this triangle. So 180 minus 107, it's going to be 73 degrees. So let's classify this now. We know that triangle BCD, all angles are less than 90. That means all angles are different. So we have an acute scaling triangle. And next, if I know that I have a 90-degree box right here and 61 of it gets used up, I can put 29 degrees here. And then that means angle W has to be 134 plus 29, 163, so 17 degrees, because this triangle is going to add up to 180 degrees. So triangle ABD is going to be obtuse scaling. And that means the huge triangle, triangle ABC, is a right from this right angle. So we have right, and then all other angles are different. So right scaling, all sides, all angles are each different. Alright, at the bottom we have exterior versus remote interior angles. Alright, and so for here, what we're saying, if we label this angle 1, we label this angle 2 and angle 3. And then let's label this angle 4. Okay, so this angle 4, this is called an exterior angle. And hopefully that makes sense because it's located outside of our triangle shape. Right? We have angles 1, 2, and 3 that are located on the inside, and angle 4 is on the outside. So we're going to call this an exterior angle. Angles 2 and angles 3 are called remote interior angles in relation to angle 4. Okay, and it's always going to be true that angle 4 is going to equal angle 2 plus angle 3. And why is that? Well, look how this forms a linear pair. So let's assume that angle 1, let's change colors here. Let's say that angle 1 we were given is 50 degrees. that means angle 2 and angle 3 also have to add up to 130 degrees. Okay, so that's why the two remote interior angles will always equal the exterior angle not adjacent to the given side. Alright, let's keep rolling. If you were told that you had a 50-degree angle and a 45-degree angle here, and this was all that you were shown, then what you could do next is you could say that I know that this angle has to be 95 degrees. And how did I get that? Well, you can just add these two up and you get 95, or you can work backwards. You would get 180 minus 95, which means this angle has to be 85 degrees, and then you can get 95. So there's two ways that you can solve for these triangles. You can use the linear pair, which is solving backwards, or you can use this new theorem that we have, which is called the triangle exterior angle sum. Alright, then let's say that you were told that you had 60 and 60 here. You would then know that this angle on the exterior is 120, and this angle would then have to be 60 degrees. Okay, and again, you could work backwards on that. Alright, the measure of an exterior angle of a triangle equals the sum of the two remote interior angles. And that's what we just got done explaining with all of these three drawings. So next to this, this is a long theorem, and we're going to call this the Keys theorem from here on out. The Keys, which is triangle exterior angle sum, and then we'll put TH for theorem. So this is called Keys from now on. It just says the sum of the two interior angles, sum of the two remote interior angles will equal the exterior angle. Alright, on problem 6, we're asked to solve for angle Y and angle X. First, let's go with our easier answer for X. This forms a linear pair, so we can say X is going to be 130 degrees. And why is that? That's by definition of linear pair. Alright, next we're going to use our Keys theorem, which says that if you measure the two remote interior angles, so 50 plus 95 equals 145, therefore Y has to be 145 degrees, and that's by our Keys theorem. Now let's say that you forgot about that, and you were unsure about Y. Remember that you can always work backwards. This is 145. There's 180 degrees total in all triangles. That means this angle would have to be 35 degrees, and then this forms a linear pair, which is how we get Y is equal to 145. Alright, next problems we're going to relabel. We're going to do this problem first, and then 2, and then 3, and then 4, and then 5. So on problem 1, we have measure of angle 1 plus measure of angle 2. Hopefully you see this forms a linear pair. So we don't know what 1 and 2 are as an individual angle, what they equal, but we know that when we add these two up, they have to be 180 degrees, and that's by linear pair. Problem 2, we have measure of angle 2 plus measure of angle 3 plus measure of angle 7. In all triangles, there's a sum of 180 degrees. So that's going to be 180 degrees. And that was our triangle sum theorem. That's the rule. That there's 180 degrees in all triangles. That's called the triangle sum theorem. Next, measure of angle 4 plus measure of angle 3 plus measure of angle 5 plus measure of angle 6 is going to equal 360 degrees. And why is that? Well, we are shown two linear pairs. Okay, and there's 180 degrees in one linear pair. That means we have two, there's 360. Alright, to the challenging ones. Let's put a little star here. I think these two are somewhat challenging. Measure of angle 7 and measure of angle 3. These are remote interior angles. And so that's our new theorem. It's our Keyes theorem that says it has to equal the measure of angle 1. And we're going to put our Keyes theorem. Alright, then measure of angle 2 plus measure of angle 7. You could have two answers here. They could equal measure of angle 4 or measure of angle 6. And remember 4 or 6 would be our exterior angle, so that would be, again, be by the Keyes theorem. And sometimes it helps to hide what you don't need. So if you look at angles 7 and 2, and you look at angle 3, we can cross out angle 5 because right now we don't need it, and cross out angle 6, right now we don't need it. And now you see that angle 4 would be the exterior angle in relation to angle 2 and angle 7. Thanks for joining us. See you next time.